Yo, what's up? C'est Yoshi Brahimini. Damn, it's too loud.
All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on exceptions. Exceptions in Python, as well as in other programming languages, refer to problems in your code. Indeed, when something is exceptional in your program, it actually doesn't mean it's a good thing. It means something has gone wrong that ideally you will somehow solve. So what are some of the things that can go wrong? So I'm going to go ahead and open up VS Code on my computer here, and in the terminal window, I'm going to go ahead and run code of hello.py. That's going to, of course, open up a brand new tab for me, hello.py, in which I can write my code. And let me go ahead and write some very simple code just to say hello to the world. Let's go ahead and say print, quote, hello, comma, world, and then let me go ahead and I'm forgetting to close that quote. So a mistake that you yourself might have already made or might surely in the future make, and it's a little subtle because you might not necessarily notice that you've just missed that one character. Well, let me go ahead and somewhat optimistically go down to my terminal window now and run python of hello.py and hit enter, and that's the first of my errors. My gosh, I've only written one line of code and I seem to have more lines of errors on the screen.
Which video is this? Okay.
But the salient point is this bottommost thing here. Notice where it says syntax error. A syntax error is a problem with the code that you have typed, your syntax. Just like English and other human languages have syntax associated with them, so does my code. And it's not quite correct. Something is awry. I didn't follow the instructions properly. And it does elaborate for me. Unterminated string literal. Now that's a bit arcane. That is a bit of a confusing error message, but unterminated would generally mean that I started something but didn't stop it. I didn't terminate it. String, of course, is a sequence of text like we've discussed before, or str in Python, and literal generally refers to something that you literally typed. It's not a variable, it's something like quote unquote, or just quote, hello world. So the fix here, of course, is going to be to go ahead and terminate that string and actually close the quote. And if I now go back down into my terminal window and rerun python of hello.py, now I'm saying hello to the world. So the catch with syntax errors here is that syntax errors are entirely on you to solve. A syntax error is a problem that you've got to go back into your code and fix from the get-go. You can't just kind of hope that it's going to resolve itself or expect that other parts of your code will catch it for you. Syntax errors just must be fixed. But there's a lot of other types of errors in Python that might be described as runtime errors that happen while your code is running, and it's really up to you to write some additional code defensively to detect when those errors happen, because you don't necessarily know, for instance, what input humans are going to type into your program, and so you better be ready defensively to accommodate things that they type or even mistype. So for instance, let's go back over here to VS Code, and let me propose that we take a look at a new file altogether. I'm going to close hello.py, and I'm going to write code of, say, number.py. So let's play around with some numbers in Python. And the first thing I'm going to go ahead here and do with number.py after opening this new tab is I think I'm going to go ahead and type up a relatively simple program that maybe prompts the user for an integer, like x, and then just prints out what x is. So we're going to start super simple, but again, in starting simple, we'll be able to really see where I've done something wrong. Well, here we go. I'm going to go ahead and say a variable called x is going to get assigned the value of the return value of input, quote unquote, what's x question mark, and I'm going to include a space to move the cursor over a little bit, and then ultimately I'm going to go ahead and, oh wait a minute, if I'm wanting to get an int from the user, recall that I need to do something proactively. I need to actually convert that input to an integer using the int function in Python. So now I'm passing the return value of input as the argument to int, and that will store in x ultimately an integer, not a string that looks like an integer. All right, let me go ahead now and just quite simply print out what this is. I'm going to go ahead and print out quote unquote x is x. But I don't want to literally say x is x. I want to plug in the value of x. So maybe the easiest way to do that is to surround it with curly braces. And then if I'm using these curly braces and I want Python to interpolate the value of that variable, that is, substitute what x actually is in between those curly braces, recall that I need to use a format string or an f string by prefixing this whole thing with an f. Now that I've done that, let's go ahead and see what happens. I'm going to go ahead in my terminal window and run python of number.py. I hit enter, and so far so good. All is well, I'm being prompted for X. Let me go ahead and type in a number like 50. All right, that seems to work. Program seems to be correct. Or is it? What could go wrong in this program, even though nothing did just go wrong? But if I run it and run it and run it again, during the running of my program, what could still go wrong, especially if I'm not the human interacting with it, but some other human instead? Any volunteers here for this one? What could go wrong, and in what way is this program not really correct, even though at first glance it seems so?
What is an interpreter? So, when we code in a integrated IDE, we can't code in an interpreter.
So I'm not calling an integer. I'm still having trouble hearing you, but what I think I heard is that if what the user types in is not in fact an integer, I can't just blindly convert it to an int. If I'm not putting too many words into your mouth, I think what I should perhaps do here is be a little defensive and let me see if I can't simulate exactly the problem that could go wrong here. Let me go ahead and run, again, python of number.py. Let me try another number. In fact, when testing your code, generally it's a good idea to test corner cases, maybe numbers that aren't quite as plain as 50 or 49 or 51. Let's choose some numbers that might be a little more interesting, if only mathematically, like 0. All right, 0 seems to work. My code still prints out that x is 0. What might be another corner case to consider? Well, let me go ahead and try a negative number. That too is pretty different in spirit from 50. -1? Okay, that works too. Well, let me try it one more time. I've tried positive numbers, negative numbers, 0. Let me try something like a cat. So literally, C-A-T, typing in a string that doesn't even look like a number, and yet let's see now what happens when I hit enter. All right. We'll see now we've got another kind of error. It's not a syntax error because I didn't make a typographical mistake. I didn't forget some piece of syntax. I actually now have an error with one of my values, and it's in a value I didn't even anticipate. The human, me in this case, typed it in long after I wrote the code. So what does this refer to? A value error. Well, let's see what the explanation is. Invalid literal for int with base 10, quote unquote, cat. Now, this too is a bit of a mouthful, and unfortunately in Python and a lot of programming languages, the error messages are written for pretty comfortable programmers. And of course, when you're learning programming for the first time, you might not be so comfortable with the programming language, let alone the error messages. But let's see if we can't glean some insight. So invalid literal. Well, again, a literal is just something that's been typed in, it would seem, for int. What is int exactly? Well, int is the function I'm using to convert the user's input to a corresponding integer. Base 10, that refers to the decimal system, which is the default that Python's using. And it looks like, at the end of the day, what Python really doesn't like is that I passed cat, quote unquote, to the int function. So how do I go about actually fixing this problem? Well, I could just add instructions in my program. Maybe I could add a line of print telling the user more explicitly, be sure to type an integer, or please don't type cat, please don't type strings. Of course, the user might still not oblige. They might not be reading the instructions. So that too is probably not an effective strategy. What we really want to do is write our code with error handling in mind. We want to write lines of code that not only accomplish the problems we care about, but that also handle errors that might unexpectedly happen. And in general, when programming defensively, assume that the users aren't going to be paying attention, or worse, they're malicious. They're trying to crash your program, so we want to handle as many errors as we can. Now, how do we go about doing that in Python? Well, it turns out whether you want to catch a value error or other types of errors as well, though not syntax error, Python actually has this keyword called try, and it's sort of aptly named. If you want to try to do something in Python, you can literally use this keyword, and you can check whether or not something exceptional, something erroneous has happened. So using both try and this other keyword except, can I go and try to do something, except if something goes wrong, I can do something else instead. So let's consider, how can I go about trying to convert the user's input to an int, except if something goes wrong? Well, let me go back to my code here, and let me propose that I now modify this example as follows. Let me go ahead and above my first line of code, I literally write try and a colon, telling Python, try to do the following. I'm going to go ahead and indent my existing lines of codes here by the same number of spaces, 4 in this case, and then I'm going to add one more new line down here that literally says except value error. and notice it's important that I've capitalized the V and I've capitalized the E. These symbols are case sensitive, and this is now an opportunity, after this colon, to tell Python what I want to do in exceptional cases, when the number or the input from the user is not, in fact, a number. And I'm going to say something plain like print, quote unquote, x is not an integer. I'm at least going to tell the user roughly what the problem actually is. So notice another detail. The indentation is important. Because I have try on line 1 and I've indented lines 2 and 3, those are the 2 lines of code that I'm trying. Except if I see a value error, line 5, because it's indented, is what is going to get executed in cases of those errors. Let me go ahead now back to my terminal window and run Python of number.py, enter, and let's go ahead and type in 50 again. Still seems to work, and of course I'm trying and succeeding. Let me go ahead and try once more, this time though with the word cat, or really anything that's not a decimal number, and now you'll see much more cleanly x is not an integer. I'm not seeing some scary error message that I, the user, am going to have no idea how to handle. Now you, the programmer, have anticipated that something exceptional can happen, and you've gone about actually handling the error for the user, giving them an appropriate error message instead. Let me pause here and see, are there any questions now on what we've just done by introducing try and except to handle this value error?
Is value error the only type of error you can get, or are there other types?
Is value error the only thing you can catch? There are other errors as well, and we'll see a few of them today, and there's many, many more, honestly, that if you continue programming in Python, you're going to see a lot of them over the weeks, the months, the years to come, but the technique for handling them is going to be largely the same. Other questions on try, except, or these exceptions more generally?
Yes. Sir, actually, to use the except block, you need to know the type of error, right? Like here, you knew it was a value error. What if you can't anticipate this particular type of the error?
A really good question. So I'm being very good about catching, so to speak, the very error that I know might happen. I don't know when it might happen, because it's going to depend on the user, but I know what kind of error will happen from the int function. There is a way in Python where you can say, except if anything goes wrong, and you can literally omit value error and just catch everything. The problem with that is that it sometimes hides other bugs in your code because you don't necessarily know what's going wrong, and if you don't necessarily know what's going wrong, how can you possibly handle it correctly? So bad practice. And put another way, it's lazy to do that, to just say, catch everything and I'll deal with it here. So a much better practice would be to figure out what kind of errors could happen and include mention of them explicitly as I've done. Now, with that said, if you read Python's official documentation, as you'll eventually invariably do, it is not great about telling you proactively what kinds of errors can be raised in this way. So it's a bit of contradictory advice. You should do it this way, but it's not always obvious what you should be checking for. But you get better at it with practice. And some of the times the documentation does spell out what could go wrong. Let me turn our attention now back to this and point out that even though this is better code, it is more correct in the sense that I'm not just leaving it to the user to see some really ugly default Python error message that most people are going to have no idea what to do with. I'm at least handling it more elegantly, and I'm printing out x is not an integer, so it's at least more instructive. But this isn't necessarily the best way to implement this code. Why? Well, here too, I'm actually still being a little lazy. So notice that I'm trying to do not one line of code, but 2 lines of code. And this isn't a huge deal because we're only talking about 2 lines of code, but in the interest of preaching best practices, you should really only be trying to do the 1 or very few lines of code that can actually raise an exception, that can actually fail in some way. I am pretty sure that calling print here is not going to raise a value error. Whether x is an int or a string or a float or anything else, the format string feature of Python is going to handle printing it just fine. So really what I'm going to do is this. I'm going to move this line 3 down to the bottom of my code. I no longer need to indent it. I'm just going to execute it at the bottom of my file here. Unfortunately, by doing this, I've done a good thing by now only trying to do the minimal amount of work necessary that might raise the exception, a value error, but I fear I've introduced a new mistake. Well, let's see. What is now incorrect? Let me go ahead and again run Python of number.py, enter. Let me go ahead and do it correctly with 50, and all seems to be well. But again, let's try those corner cases, the zeros, the negative numbers, or in this case, the cat. Let me go ahead and type in CAT again, enter. Now I have a name error. So now it's yet another type of error in my code that I've introduced here. And what does this name error mean? Well, just as a value error refers to that, the value of some variable, the value that someone has typed in is incorrect, name error tends to refer to your code. Like you're doing something with the name of a variable that you shouldn't. And why might that be? Well, let me turn our attention back to the code here and consider, what is it complaining about? Well, the name error is what I see down here, and it's telling me name, quote unquote, X is not defined. And notice if I look further here, it is mentioning line 6. So I know the problem is with my code on line 6. And that worked a moment ago, and I'm defining X on line 2. But let me ask the group here, why does X not in fact exist on line 6? Why is it not defined, even though I'm pretty sure I was intending to define it on line 2?
Maybe the scope of the variable is between the try block.
So good terminology. Scope refers to the portion of code in which a variable exists. That too, though, isn't quite right in Python. That would be true in C, C++, and Java, where indentation or curly braces tend to define the scope of a variable. But again, here in general, and this worked a moment ago, X exists once it's defined on line 2, because remember, I printed out X is 50 a little bit ago. Let's try one more hypothesis here. One more hand. Why is X somehow still not defined?
Yeah, so is it because it's local variable, meaning that like it doesn't define outside of the scope? Because like what people have mentioned, it prompts the input in try, right? But outside of it, it's undefined.
So still good instincts and good terminology too. There's this notion of local variables, which tend to exist inside of functions, for instance, global variables, which tend to exist in entire files. In this case too, though, that's not quite the case. What's happening here boils down to order of operations. Let me come back to the code here and recall that anytime we've discussed the assignment operator, the single equal sign, that copies a value from the right to the left. But consider for a moment at what point something is going wrong. Well, the input function is probably working just fine because we've used that a lot now to get users' input. It always returns a string or a stir in Python. But what could be going wrong? Well, if I'm passing that string to the int function as its argument, it's probably the int function that's erroring. And indeed, if you think back earlier when we had the value error, it was in fact the int function that did not like quote unquote cat as input. So this is all to say that this portion of my code, highlighted now to the right of the equal sign, that's the code that's creating a problem. That's the code that was creating a value error. And in this case, we're catching the value error, but because the value error is happening on the right of the equal sign, there's no value being copied to the left. The error is interrupting that whole process. So even though we see x equals ... on line 2, the portion of that line to the left of the equal sign isn't getting evaluated ultimately because the value error is happening too soon. And so when we finally get down to line 6, even though it looked like I was defining on line 2, and I would have defined x on line 2 if all had gone well, we didn't get to the part where the value is copied from right to left because the value error happened first. So this code is just incorrect now. So how do I go about solving something like this? Well, it turns out that there's another feature of the try and except syntax that Python supports, which is that it also supports the keyword else. Now, we've seen else before. If you think back to our discussion of conditionals, we saw if, we saw elif, we saw else, which was kind of this catch-all, what you should do in the event that nothing else is relevant. That's kind of the same intuition here for the try except feature of Python. What you can do is this. You can try to do the following, as I've done, except if this goes wrong. But if nothing goes wrong, else go ahead and do this. So this is one way I can solve this same problem now. No matter what now, Python is going to try to execute line 2. If something goes wrong, it's going to execute lines 3 and 4 to handle that value error. However, if you try and this code succeeds, then there is no exception to handle, so you're then going to execute this line here. So it's a little confusing perhaps in that we're now using else both for conditionals, if, elif, else, and we're also using else with these try except blocks, but that's okay. That's part of the language. That's one of the features. So now if I rerun this code in my terminal window, Python of number.pi, let's do something correct like 50, I see that x is 50. So line 1 is executed. We're trying to do the following. Line
Do
2
the
is
cat.
executed because the conversion happened successfully, so we ignore the result. Type in cat or again any other word and hit enter now. We don't see what x is, rather we see quote unquote x is not an integer, which is what's being handled in my except clause. All right, let me pause here because that's a lot of new syntax and see here if there's any questions on try, on except, on else, name error, or value error.
Well,
Can you
people.
please repeat try function?
Repeat the name error. What's the problem with the name error?
Yes, yes.
Yeah, so let's
Okay, I gotta head to work. Peace out, YouTube. I'll let the Twitch stream run in.